Good afternoon, everybody. It's 4 o'clock. We are live. We are here. And I hope you all are with us tonight and can now hear me talking to you. My name is Hiemisch. I work for the Fraunhofer-Institut for Windenergiesystems. I am the person responsible for communication and public relations in the Hydrogen Flagship Project H2Mare, and I will be your webinar moderator for the next, hopefully sparkling 90 minutes. Saying that, it is now my pleasure to welcome you to our H2Mare Dialogue. Well, when I take a look at today's registration list, I'm glad to see that obviously more than 200 people have joined us today and are curious about the latest research in green offshore hydrogen and power to X production. Well, that's truly fantastic. So let me tell you, I'm also curious about the presentations of our speakers, of course, which are going to start in a minute. But first of all, my curiosity also leads me to a question for you. I've already seen some of you have started to introduce themselves in our chat. So if you like to type in from which destination you are joining us tonight, and let's see how international our audience is today. So no matter what your answer will be, I'm sure all of you are united by at least one common aim today. You are here to find out what is currently going on in H2Mare. Together with H2Giga and TransHyd, it is one of the 3 hydrogen flagship projects funded by the German Federal Ministry of Education and Research and contributing to reaching the goals of Germany's national hydrogen strategy. Now, for giving qualified answers, we've got an exciting program ahead with the following expert speakers. Ivo Gebhardt from Technische Universität Berlin. He will give you an overview about the current design and an insight over the development process and future challenges of the PTX Wind trial platform. Dr. Laura Schmidt from Helmholtz-Zentrum Hereon will speak about social acceptance for the realization of offshore hydrogen technologies. And we've got Oliver Bagemiel, my colleague from Fraunhofer IWES. He examines the field of seawater treatment for offshore application. So after each speaker, and if we don't run out of time, also at the very end of the event, you'll get the chance to ask your questions in a brief Q&A session via chat. So don't hesitate to text our experts. That's why we call it a dialogue. So before we jump into the presentations of our guest speakers, we are going to start now with a short introduction into the giant ocean of H2Mare activities presented by H2Mare coordinator Matthias Müller from Siemens Energy. So lean back and enjoy.
Thanks for the warm welcome, Kirsten. I hope you can hear me and see me, and I think, yes, the slides are coming up as well. Great. So, yes, thanks, and also from my side, a warm welcome. I have the pleasure to basically do things, give you a bit quick overview, but I hope, and I guess most of you already know what H2Mare is about. In a general sense, still, I want to make sure that everybody knows where we are coming from and what the bases are, and obviously also an update of where we are really right now, what are the events, what has been happening, what is happening. But as Kristen is saying, we're going to obviously get more details from our 3 expert speakers that will talk after me. So quickly just mentioning the other 2 flagship projects that Kristen already mentioned. So H2Giga, besides us, is really looking at scaling up, so industrializing electrolyzer manufacturing. TransHyd is looking at transport and storage of hydrogen. And for us, for H2Mare, as Kristen was already saying, it's really about the almost autonomous production of green hydrogen offshore, where we actually have the wind to make hydrogen green, so to speak, but also looking at power-to-X products, so to take it a next step further. We do that with over 30 partners in 4 different projects organized. We have an overall project budget of 150 million. And since a lot of small, medium enterprises, but also research institutes and universities are involved, the funding itself is more than 100 million. And as you can see, we started already 3 years ago and are still have about 1.5 years to go. This is basically what we're looking at from a, let's say, organization point of view, but also content overview. On the left-hand side, you see really the wind turbine, what needs to be done different, better, in a more optimized way to get the most out of the wind for hydrogen production. That's what off-grid wind is all about. Looking at the electrolyzer itself and what we need to do in a different way to really optimize the interaction between a wind turbine and an electrolyzer is what H2Wind is about, which is the second project. Then the third project really focuses at the next step after hydrogen, so power-to-X topics or further power-to-X topics, and the respective platform, which we also will get some further insights at the end of our talk today. And overall linkage is basically done by the project that we call Transfer Wind, which focus at topics less of a technical nature, but more of health and safety, the environmental topics, stakeholder engagement, the entire educational aspects, regulatory aspects. So all the topics that concern all of the other projects together. So that's how we are made up. And here you can actually see all the different partners, universities, small, medium enterprises, research institutes, but also big players that are involved in H2Mare. But now actually focusing on where we are, what is happening right now, just to name a couple of highlights. So the interesting part that basically just went into commissioning and is running now is the water treatment. So the real tests that we started up in Bremerhaven to really see which purity levels we can get to, how much topics do we have with regards to maintenance, because this will be a crucial topic, and Oliver will touch this in a bit also later on. We are in the final installation phase of a 2 megawatt scaled integration test up in Brande in Denmark, where we then actually want to see what's the interaction of a wind turbine and the electrolyzers. How does this work in reality? Because you can simulate so much stuff, but you really want to see how the real stuff works and what experience you can gain. At the same time, actually right now where I'm standing about 50 meters away, we're about to do the final assembly of the first offshore electrolyzer short stack. So to really put the electrolyzer design that we looked at, or the stack design that we looked at for offshore together, and to really start testing those topics. We will, at the same time at KIT, so in Karlsruhe, we have the Fischer-Tropsch container that is in its final installation phase for the onshore trials, before it will then be put on the Power-to-X trial platform for actually offshore trials, which takes me to the next point. So the actual engineering of the Power-to-X trial platform is also in its final stage, and Ivo from TU Berlin will touch on that in a bit more detail as well. And then, as I mentioned, also as part of Transfer Wind, so the overall engagement with the public, we had a lot of successful events and publications in the last year. and are striving to continue the same also for this year with regards to really two-way stakeholder engagement, and Laura will also touch a bit on that in a minute. So those are really the topics that are driving us and keeping us awake at night in a positive sense right now. But we are also already thinking about what comes next. So I just mentioned we have about 1.5 years left. We are constantly checking how far we got, what we still want to achieve, can achieve in this project, but also what is beyond H2Mare. So what do we need to tackle, need to be looking at next, because this is just one of the big steps. It's not the final marking, and obviously the voyage is going to continue. So this is also something that we already discussed right now. But for right now, let's basically get back, Christian, to you, and then hand over to the experts and enjoy the talk.
Yes, thank you very much, Matthias, for this overview at the beginning of our event. And yeah, as we've got a tight timetable today, there's no Q&A session planned after this brief introduction. But if you still have questions about H2Mare in general, I recommend you visiting our website, wasserstoff-leitprojekte.de, for further information. Now, don't waste time and start with the first technical presentation of today. Ivo Gebhardt works as research assistant in the field of design and operation of maritime systems at Technische Universität Berlin, and he's now going to give you an overview about the current design and an insight over the development process and future challenges of the PTX trial platform, which is developed in the H2Mare project PTX Wind. Here we go.
Hello, everybody. I hope everybody can hear me. Thanks for the warm welcome from Christian and from Matthias. And just a quick word about me. I'm a maritime engineer and work in Technische University of Berlin. And we are responsible together with other partners for development for the PTX Wind trial platform. And like just introduced, I would just like to give you a short overview over what has been planned and what will be the next step in the future. First of all, I like to come up with a small reminder to ourselves. It's written in green: the ocean is a scary place. What does that mean? When you have on the left side a small picture where this might be a bit more clear. You have wind, you have waves, you have very hostile environments where you're in. I mean, if you look at the sailors from a couple of hundred years ago, they were seen as like the astronauts would be seen today. It was when they went to sea, it was not very clear if they ever would be coming back or would they ever see land again. So yeah, there has been a lot of developments in the past decades and centuries to make it more safe and to make it more accessible. Now we are actually at the point where we plan on, or we are putting wind turbines out on the open sea, and now we want to take the next step and want to try for the first time ever, at least to our knowledge, to put real PTX structures in this hostile environment. And this will come with a lot of challenges, expected and unexpected, of course. And it is a combination of different traits and different aspects from different industries, and that makes it very challenging, but also very interesting. We have not, in different regards, have prior experience in realizing this, of course. So, of course, the first thing is to try it out. In this context, is very important to, like I just said, is safety for everyone involved. So everyone who wants to or who will be going out to sea, and all the equipment must return safely back home. This is the uppermost important aspect, and there is no compromising on this premise. also, what is not seen in most instances is that there is also a big side of laws and regulations where it is actually tested whether the laws that are currently in place are suitable for this sort of thing we're doing. So everything that applies to structures on land is it enough to get these regulations out for the structures at sea, and also are the regulations which apply for structures at sea currently, are they suitable for PTX? So that's like a back and forth, but it's also a very important part of this research. Okay, what's the basic idea if you've never heard of all this platform and PTX thing? So, of course, it's our aim to go for renewable energy and to become CO2 neutral. It's like the overriding topic, of course. And it is said that there will be a PTX project realized for Fischer-Tropsch products in a small lab environment, let's say just container size, and test that whole system first of all onshore. There's different aspects, not just one plant, but several different structures which have to be connected together, of course, and they have to be thoroughly tested. It has been decided for the first try to go for the Fischer-Tropsch because it's one of the most complicated things you can actually try offshore or in any PTX environment. If you come like from the more easy substances would be like hydrogen or maybe methane, but to get Fischer-Tropsch products like oils and waxes is a very complex endeavor. And after testing it all onshore, it will be installed on the offshore platform. The whole structure, like I said, just basic idea, not exactly what we are 100% doing, but the whole thing would be shipped out onto the wind park or connected to wind turbine and get a supply of green energy directly from the source, from the wind and from the energy. And you could use the water from the sea, desalination, and just get your hydrogen and all the different components you need, and you would extract the CO2 from the atmosphere, of course by direct air capture, and then all the discharge water would be treated and then discharged into the ocean. And of course, the Fischer-Tropsch products would then remain and then be transported to land. That's the basic oversight. What will be actually the scope of the project is first of all like a twin-fold structure. You have first of all Fischer-Tropsch production process plant, which is developed in coordination between KIT and the DRRTT, those are down in the south of Germany, and there will be an additional direct air capture, like I just said, and a CO2 buffer, and of course the aforementioned water purification and wastewater treatment facilities. But just a quick note, there won't be any discharge of wastewater into the ocean before anyone asking afterwards, because just for the first trial, we were just analyzing whatever comes out of the process, but there won't be any discharge into the water. These systems then need to be converted for temporary offshore use. I highlight the term temporary because, of course, if you see the actual container on the right side of the slide, this sort of structure to get it offshore certified is a really difficult task. So on the other side, we need to take this into account when we plan the platform itself. Exactly. This is the second part of the whole platform is of course the platform itself, where all the different different containers and different processing plants will be installed on. We start with a floating structure because it's much more flexible, gives us much more flexibility when it comes to redesign, or if there's a failure point. If anything is installed on a fixed structure offshore, it pretty much remains there, and it's really hard to do any maintenance. So we went for the flexible, first of all, for the flexible solution of a barge, and like you would see on the right side of the slide, this sort of thing. And based on that, we were building designing the site. The picture you would see on the bottom. It will include shelter for personnel. I don't say accommodation because it's just a temporary shelter for breaks, or if there's bad weather. There won't be any like overnight stays on this platform because it complicates things on different levels. Of course, there will be suitable safety equipment and like rescue buoys and stuff like that. You will have a central control station where all the different aspects of the platform will be connected and then can be controlled from there. You have different storage and maintenance facilities for quick maintenance and for storage of the products, and or for the produce and products. And of course, there will all these different containers have to be interconnected. So you have to plan for cables, for pipes, and account for different temperatures and pressures, of course. And also, this platform includes its own energy supply. So for the first step, we opted for not connecting it to a wind park because it would just complicate things even further. But it would still be an option maybe for future development or future thoughts maybe. Of course, you have to get to and from the platform, so you need to take this into account for accessibility and logistics. And like I said earlier about the different offshore types of containers, they are not 100% watertight or suitable for these conditions. So we have to add further protection against the open sea and against water ingress, because it's a very precious container, and we don't need we want any damage on these. Okay. Then let me just quickly talk to you about the actual layout, what we have chosen. On the left side, we have the Fischer-Tropsch process plant, and there are two containers in this regard. We have the direct air capture on the bottom. We have several different storage facilities. We have in the middle the generators, like a generator and a backup generator, and some the storage for that. And we have the water treatment, which means the freshwater and the wastewater treatment. We have a small workshop for maintenance, and like I mentioned earlier, all the quarters for the personnel and control facilities. This has all been integrated, interlinked, and this is the site view again, just quick measurements. It's now at the moment it's thought about it being 60 by 16 meters with about 3.5 meter freeboard. So the side of the structure, which is painted yellow in this instance, will protect you from the waves on certain conditions. You have a mooring system for putting the platform at its place where it needs to stay for a couple of trials. And you have this surrounding, like say, wave breaker, which will counter any overgoing sea onto the platform. And on top of that, you have a false floor. All the containers are still raised on the inside. So if any water is getting into the structure, there will be no contact with the containers because they are raised approximately 1 meter from the floor, and all the water can then drain out, and you won't get wet feet when you're working in there. Like I said, no accommodation, because the people work there and then get transported back to land. What's the action plan? Where would we want to do these experimentations? It's still unclear where exactly we want to build the platform, but our best contenders are these 3 ports or these 3 cities in Germany. It depends on the tender where we will be. We will be actually building it, but the first test will be on site or in situ where the platform is actually built, and then there would be some nearshore tests close to the coast. It depends on where we're actually building it, and the big vision is to get the platform out until, why doesn't it work? Out to Helgoland for the final offshore test close to the Helgoland island. And each of these bigger tests, like the nearshore and the offshore tests, are planned to be approximately 2 weeks during the summertime. So when it's more likely to have nice and stable weather conditions and not the big winter storms, because like I said, it's still a floating structure and it's kind of valuable. You don't want to sink into the North Sea. What's the timeline? We are now in the beginning of 2024 in the planning and construction phase. We are starting the tender phase, and until the end of the year, there will be start for manufacturing for all the different platform components. And in the beginning of next year, there will be assembly and decommissioning. And the first tests will start as soon as the weather would be suitable in the springtime, and after that we will be doing the nearshore and the offshore tests before it then will be sadly disassembled at the end of 2025 before the project ends. Learnings and conclusions. What have we learned so far, and what will be in the future? It was quite a steep learning curve to cover all the to consider all the laws, rules, and regulations surrounding this topic. Like I said at the beginning of the presentation, it's an ongoing process. We're still learning, but anyone who will ever do this kind of project in your country or whatever, please take into account all the rules that are in place, because it plays a big role. You can have the biggest ideas, but if it's not suitable for realization, then it just falls short. You always should have an open mind approach to problem solving. Use the simplest solution you can do. In most cases, makes the life a lot easier. You have different regulatory problems you have to overcome in different aspects, and you need to prepare for this. It's always important to talk to people from different backgrounds to get the best information and the best solutions to problems. And of course, the whole thing is a start for something much bigger. There are bigger and more elaborate structures and plans in the future. So yeah, this is the first step on a long time plan. And yeah, we can't wait to continue the process. So yeah, that would be my last statement for that. I am Ivo Gebhardt. You can see my email address here if you wanted to get in touch, to get into to some talking, and I will be happy to take some questions if you want.
Thanks a bunch, Ivo, for sharing those insights about the Power-to-X trial platform with us. One of the major things that are developed in H2Mare. Thank you very much. So I'll stop your presentation, and there might be some questions for you to answer in the chat. Let's see what we've got. So there's a first question by Gianluca Caridi. He's asking, is the offshore structure for Fischer-Tropsch fixed or floating?
It's fixed to the platform, but the platform is floating. What is that? Is Is that the answer to the question?
We hope so. We've got another question by Gianluca. He's asking, what is the size of the barge?
I think it was answered in the presentation. It's 60 by 16 meters.
Okay, thanks for that. Another question by him. He's also asking, where is the hydrogen production module? Is there hydrogen storage as well?
There is hydrogen production on board, and it's in these process containers I showed you on the left side. There's everything that needs to be done surrounding the PTX production, starting with water, is done in these containers.
Perfect. Another question from Wolfgang Schleifenbaum, who is asking, are there legislative regulations which forbid the discharge water into the ocean?
Yes, there are. That's why we are not doing it at the moment. It depends. It's a very complicated topic. So for the first step, we said, okay, we have to analyze what's actually coming out of the process. We won't be doing at the moment any discharge into the ocean.
There was a second part of the question. What would you need to change to be able to discharge?
First of all, we need to find out what actually, like I said, comes out of the process. How many ppms of this and this solutions is in it, and then we can figure out if it's actually safe for discharge. And until then, we will just hold on to the process water.
All right. Many questions now arriving. So Gerd Zinke asks, which kind of stuff will be necessary during a normal process? Does it need a permanent control on board, or will it be in a remote modus?
Also for the normal regulatory reasons, there will be always people present on the barge. But it's planned to simulate a remote controlled process. But just for regulatory reasons and for safety reasons, of course, there will be someone present at all times.
Mm-hmm. Feriel Mustafa is asking, would you consider a direct seawater electrolysis in the future?
Direct seawater electrolyzers. I think there's a lot of research being done in PTX wind as well. But on this platform at the moment, no.
Mm-hmm. Dennis Mulder asks, why power to X offshore? I understand hydrogen production offshore, but why not transport the hydrogen to land and then produce Fischer-Tropsch products onshore?
That's a valid point. The thing is that we are at the research phase where we want to figure out the best way what's the best way for PTX production in the future. Hydrogen, of course, is easier to produce, but then more difficult to transport. So we want to make sure we go for the best solutions in different scenarios, and to test if it's actually possible to be like overall on the better solution, and then just go for the pure hydrogen production. That's the aim of the whole project.
So we might have enough time for a last question by Julio Cesar Garcia Navarro. He's asking, what are you doing to the brine from desalination? Are there any particularities about discharging it directly to the sea?
No, we are not discharging anything into the sea. That's what I said. The brine gets collected and then analyzed, and then after that we can decide if it's actually safe for discharge or not.
All right. Thank you to this point. We've got some more questions, but I think we can also try to answer them via chat, because we now need to move on to our next speaker of today. She is currently working at the Climate Service Center Germany, an institution of the Helmholtz-Zentrum Hereon, on issues of stakeholder engagement in climate change and adaptation research projects. In H2Mare, she's conducting research on the acceptance of offshore hydrogen and Power-to-X technologies among stakeholders, and supports activities for the engagement and information of the public. Therefore, her presentation is titled Social Acceptance for the Realization of Offshore Hydrogen Technologies. Welcome, Dr. Laura Schmidt. And your presentation is going to start now.
Perfect. Thank you very much, Christian. Thanks a lot also for the invitation. So today I would like to shed some light more on the social side of this offshore hydrogen technologies. I would like to give you some insights why social acceptance is crucial for the energy transition. And I also would like to present some of the activities that we are doing in H2Mare in this regard. We, that is me with my colleagues Nadine Stübel from the NGO UCCD and Sanjay Bone from the Foundation Offshore Wind Energy, and we jointly work on all these topics of acceptance research, stakeholder engagement, and knowledge transfer. But before I dig deeper into all these topics, I would like to give the word to you, to the audience, and ask you a question. What do you think about, what the Germans think about the about the energy transition? This sounds now a bit complicated, but maybe, Christian, you can start the first poll question. And let me know if it works.
So it started.
Okay, so the first question that we would like to ask you is, what do you think, what the Germans think? The German population considers the energy transition to be very or exceptionally important, not so important, or not important at all. Okay, so we have almost 100% very important or important. Thank you very much. And right after that, a second question, again, what do you think about what the Germans think? The German population supports the idea of renewable energy facilities in their neighborhood. Can you make the second question, please, Christian?
Yes. It's
perfect. Yeah. So renewable energy facilities in the neighborhood, how much do they support it? Very much, much, little, or no support? Okay, you do not trust them too much, so only 60% think it's rather just little or no support when it comes to facilities in their surrounding. Okay, perfect. Thank you very much. Can I just proceed with the presentation? That's still there, right? Christian, yeah. Okay, so let's see what the Germans actually did say. So in this survey among the population, we find that, and that's very close what you thought it would be, that almost 90% of the Germans think that more renewable energy is very important or important. So there is a high support for the energy transition. However, asking these very same people to what extent they would support it if there is this such a facility in their direct surrounding, in their backyard or neighborhood, we see that this is then the support only by 64%. So it is higher than you thought, luckily. And it's also, for example, much higher than in the case of coal or nuclear plants. Interestingly, if people had already experience with such facilities in their surrounding, in their neighborhood, their support is higher than those who actually do not have any experience so far with such facilities. So, but you see already that depending on the questions you ask and the angle you look at it, acceptance can change very much. And in acceptance research, we distinguish between 3 different types of acceptance. This is on the one hand, this socio-political acceptance, what we just talked about, the very general public attitude towards the energy transition, then the market acceptance, which refers more than to the investors, the producers and users, for example, of an energy carrier. And lastly, we have the community or local acceptance. So this is where we have not so much acceptance more than you thought, luckily, but still this is where most of the conflicts actually arise. And that such conflicts, missing acceptance, can even lead to resistance, and that projects cannot be realized. Probably all of you know from your hometown, from your home countries, similar examples. In Germany, for example, we have a lot of citizen initiatives against wind energies. If they form protest, it can even lead that such projects have to be stopped, cannot be realized, onshore wind farms, for example, but also looking more on the socio-political acceptance, like in the case of carbon capture and storage. Here 10 years ago, discussions are rising now again. This new technology could not be tested and laws could not be passed because of missing acceptance and a lot of resistance from the public, but also by stakeholders. Now, the topic of hydrogen is still quite new. So here we still don't know yet to what extent the public does accept it. In surveys that have been done, we see that it is actually quite seen positive. People know about hydrogen and they think it's an important part for the energy transition. However, if they are asked in more detail, we see that many people still have really big knowledge gaps. So they know what hydrogen is in principle, but they don't really know what is green hydrogen, how is it produced, what is it used for, and why do we really need it as one part to combat climate change. So how are opinions often made up? It's the media. Often what we read here about hydrogen is, for example, that green hydrogen remains way too expensive. We also find first newspaper that say, okay, now pipelines are coming, talking about very dangerous substances that are going through nature conservation areas and private property. So here we see already first conflicts rising, but we also see articles that talk about the green gold of especially the global south. So the big hope in hydrogen, but also like in this last highlight, where they hope that the North Sea becomes the big hydrogen power plant. But if you think about this, okay, North Sea should become this big hydrogen power plant. It's not only about, putting there some more infrastructure, but this whole energy transition must be also understood as a whole societal transformation. We have changes in the ecosystem. We also changed the infrastructure also in the coastal regions. With this, we changed the landscape in these coastal regions. This might change economies. We have new jobs coming up there. This changes also local identities. And if you really want to realize this whole energy transition, we also need to think about the societal transformation, and we need, for it to be successful, the passive and also active acceptance by stakeholders, but also by the public. And therefore, the aim of acceptance research is now less to really create acceptance. So we do not want to convince the people. However, we would like to understand the concerns and fears people have. I mean, it's legitimate, things change and they do have concerns. We want to understand these. We want to find methods together for the co-development of acceptance solutions. So if we include them in an early stage of a development phase, we can find together solutions that are more accepted. And we also want to learn from such conflicts for the improvement for the future planning. And very similarly, in H2Mare, we also would like to understand these existing concerns and fears among the stakeholders. We would also like to inform and exchange with the public, especially in the coastal regions. And in the end, we would like to develop some recommendations for the future implementation of such technologies. And with this, in the second part, I would like to give you now some insights on the acceptance research and activities that we are doing in H2Mare. Here you see just a rough overview. Well, we started with the stakeholder analysis. We wanted to identify the relevant stakeholders and their different roles. The acceptance analysis is basically ongoing. We talk to stakeholders, we interview them, we are planning workshops at a later stage, we do little case studies. We are having some citizen dialogues where we invite coastal citizens to learn about the project and to discuss with us their ideas, concerns. And then more on a knowledge transfer side, EUCCD is planning an exhibition for the more interactive knowledge transfer. They just published a magazine last year, Meer und Küste, where they also inform on the project and also on the energy transition in coastal regions. We can put the link to this magazine also in the chat later. And SOW is doing some knowledge transfer events that is more about the exchange with the expert community. But today I would like to discuss in a bit more detail the three upper activities. So we started with this stakeholder analysis. We wanted to find out who are the stakeholders that are potentially affected by or affecting offshore hydrogen and PTX production and also the landing. And with this, we basically looked at this whole value chain, not only looking where could this be built in the end, and we definitely have conflicts in use in the sea. In the top part, you see the map of the German North Sea, which is, you don't need to understand it, but basically each color stands for one usage. So the North Sea is already packed. We have big plans for more and more offshore wind energy, and now the hydrogen PTX on top. There are also, of course, topics like the noise or emissions, leakages. We just heard such topics in the talk before. Questions of the traffic that will increase. How are the products transported? And what does this then mean for the coast and the infrastructure at the coast? And also, what does it mean for local benefits at coasts? What jobs will be created? What does it mean for regional development? And looking at this whole chain, we identified this rough overview of stakeholder groups. So just for you to know who we are talking about, we talk about wind farm operators in the offshore industry, but also those here in red that are more affected by these plans, like fishery, shipping, environmental NGOs that do care for marine ecosystems. Also in the coastal region, then maybe the tourism or communities that might be affected by the new infrastructure. We have, for example, ports or regional development agencies that see a big new development in such industries. And then, of course, we have administration ministries that basically set the scene for this future technology. In the next step, we wanted to understand a bit better the positions and opinions of these different stakeholder groups. And therefore, we started some interviews with representatives of these different groups, 33 in total. And we used the so-called Q methodology. We gave our interview partners 30 different statements that all address different aspects regarding acceptance of such offshore hydrogen technologies. And they were asked to allocate them on this sheet to what extent they agree or do not agree to these statements. The goal in the end of these interviews is to identify groups with similar positions, and this analysis is still ongoing. But what we can see so far from these interviews, we see that for most of our interviews partners, the energy transition and also green hydrogen is considered as highly important. So nobody really questions climate change and the need for new energy carriers. Marine protection is also a very important topic for all interview partners. So it's not only a topic on the agenda of environmental NGOs. The often anticipated missing acceptance due to the risk of explosion was actually not confirmed. Everybody thinks we will be able to handle this. However, there was some reluctance towards the offshore production of PTX. The current political developments put a strong focus also on energy independence. And then on the other hand, talking with them about what could be the impact for the coastal communities. Is it rather a risk or potential for them? Here, the assessment differed among the different stakeholders. And lastly, all think that transparent information and engagement is very important. However, nobody really knows who is responsible for this. So these are just the first insights from the stakeholder interviews, but we also wanted to learn more about what actually the public thinks about such plans. And since these technologies are still in their development, it was difficult to find people to talk about this who already have an opinion. But then we found the example of Helgoland. We heard it before. It's a small and quite remote island in the North Sea of Germany. They do have experience with offshore wind energy. So you see the wind farms there at the horizon. The island serves as a base for the technicians, and also some plans for the offshore production of hydrogen have been discussed on this island. So that was for us the perfect example to go there and to learn from their experiences and the opinions there. So we did some interviews again here with representatives of the municipality, of tourism, nature conservation, and so on. We talked to people on the street, 30 in total, and by the end we organized a citizen dialogue there. We invited the people from Helgoland to learn about the project and to discuss with us the questions they have. Just very quickly, the main aspects that we did identify for acceptance in this case study, it was not so much actually about the technology as such, but the topics that we discussed much more was about procedural justice. So people asked about local benefit. How can they actually benefit from such projects in their community? They asked for transparent communication. They want to know what's going on in their community, what are the plans and who's the driver behind it. And they also talk a lot about participation. They want to become involved in such planning processes and become part of it. Besides that, we also found, compared also to the surveys I mentioned in the beginning, rather little public knowledge on hydrogen, even though it was a topic already on the island. People know what it is, but the whole value chain and the need for hydrogen is often not very familiar for the people. So here we need much more information. But with these little insights from the case of Helgoland, we see already that it aligns very nicely to what is actually known from literature on acceptance factors for renewable energy facilities. I picked a study here by Hübner and colleagues that identified 5 factors that do influence acceptance on the ground when little projects are planned. This is on the one hand the economic effects, so questions around costs and benefits. It's then much about the attitude towards the energy transition. So only if I think it's something that is necessary, I can also support such technologies. It's about the trust in actors. So question again about communication, participation, that then also leads to higher acceptance. The impact on nature and human beings. So my personal risk perception of this technology. And finally, the social norms that influence my acceptance. What do my neighbors think? Do they support these developments? Does it fit into the local identity of our community? Or this influences acceptance? And with this, I hope that you can already see that the often used "not in my backyard" label is way too simplistic. It's not that people are just against this technology in their backyard, but it's really this very complex interplay of very different factors that in the end influence if such technologies are accepted in the local context or not. And with this, just a short summary and outlook. So I hope that I could have shown you that acceptance really depends not only on this technological feasibility or its economic efficiency or ecological impact, but that it's also much about, or even more about, aspects of procedural and distributive justice. And even though that offshore might be out of sight for most of the people, if we look at this entire value chain and also think about the transformation processes it involves in the coastal region, we also need to think about acceptance in this offshore context. And acceptance thereby always remains fluid. So these studies are always just a snapshot. Acceptance also always changes along the development process. So this is also we need to keep in mind. And with this, my kind of take-home message is to really, for everybody involved in similar processes, for the energy transition to be successful, we do need acceptance. We do need social and public acceptance. And for this, it's important to inform on the projects we are doing, also to be transparent about existing risks and uncertainties that we do have, to engage with different stakeholders and people, include them more in our planning, and to create dialogue so we can build up a mutual understanding for these different technologies. And looking at the time, I would say we skip the final questions to the audience. And instead, I would like to thank you very much for your attention, and I'm happy to answer your questions.
Thank you very much, Laura. No energy transition without social acceptance. Well, I reckon we still do have the time to do your last two polls. So if you like to, we can start.
Sure. So it refers to my last messages on information and communication. So our first question would be, what aspects of green hydrogen, and I assume most of you are coming from the field, do you think should be communicated more widely? And as the answers are quite long, I think I will let it read by yourself. And I think it's just one answer possible.
Just wait for a few seconds because there's a slight delay. So now the answers are arriving.
Okay, I guess it's probably also a mixture that we need to communicate, but I see there is that hydrogen is needed for the decarbonization of certain industries. Yeah, I think that's something that is not so known yet by the public. Okay, thank you very much. We take that with us also for our information activities. And the last question would be, what do you think is the best way to inform the public on hydrogen and PTX technologies? Is it more events, inviting the public, site visits, like in our case, our little PTX boat? Should it be more on education in schools or museums, newspaper articles, or social media? Okay, social media is always a big topic, of course. Yeah, and also education. Okay, thank you very much. So I hope this is also maybe inspiring for some of you of the audience.
All right. Thanks a lot again, Laura, for this presentation. And as I was told that my live video was a bit behind, I now have turned it off. I hope that's not too confusing. But now let's turn to your questions again. Let's have a look. There's one question by Alexander Kozun. He asks how much acceptance of renewable energy differs by people from Western and Eastern Germany.
Very interesting question, but I actually have no idea. I don't know. I'm sure there are studies, but I don't know. I know about results that are looking more at the age. So younger people do accept it to a higher degree than older people, but I do not know results from Western and Eastern Germany, sorry.
Right. Matthias Franke is asking, are there any actions H2Mare is taking from the study?
Yeah, I mean, the studies are still ongoing. So the acceptance research is an ongoing task. The actions we are taking, I mean, they have been planned before, but of course, we learn each time from the first citizen dialogue we made and try to improve it for the next one. And we, try to be, I think everybody becomes more and more involved in different public relations activities or to be present at different events, to always present the project and also to consider this topic if we talk about further projects.
Maybe last question by Fawad, Dr. Mohammadi. Is the German public aware of the costs they will need to face with implementing hydrogen production and infrastructure? If they are not aware, how big will the influence be on the acceptance?
Also, interesting question. I mean, I haven't made these surveys among the German population myself, so I don't know the details about it. The cost is quite popular. You read it a lot in newspapers, so I think hydrogen being the champagne of energy carriers and so on, it is a topic that is discussed and that is known, but I do not think, looking at these surveys where they say really people do not know in detail about green hydrogen, that they would know about the exact cost they will need to face. I think it's also difficult to really put it into clear numbers. I mean, if they're aware, it would have an influence on the acceptance. So it depends on who has to pay the price for it in the end for the hydrogen. And then that's known from different surveys that the price makes a lot on acceptance. So if people get cheaper energy through the energy transition, they support it, of course, much more than if they have to pay higher prices in the end. I hope this answers a bit the question.
Okay, thanks, Laura. Unfortunately, we are not able to answer any of the questions because of our tight schedule, but thanks for your questions. Maybe there's time left at the end of the event to answer some of them. And now we are already proceeding to the last speaker of today. Oliver Bagemiel has been working as research associate at Fraunhofer-IWES since 2014. In 2023, he moved from the rotor blade to the test field wind and hydrogen division. His main competencies include process evaluation for the IWES Hydrogen Lab, as well as support for the development of a test infrastructure for a seawater desalination system for the direct coupled offshore hydrogen production within the H2Mare project H2Wind. His topic for today, seawater treatment for the offshore application, and the stage is yours, Oliver.
Yeah, hello everybody, and thanks Christian for your warm words and for the introduction. I'm happy to be here today and that I can give you a short overview about the things we have done on the topic of seawater treatment for offshore hydrogen applications. And my plan was to introduce myself, but I think that's already done, so that I can skip to the next slide. And yeah, as Matthias Müller mentioned, H2Mare is a research project with the goal of an autonomous offshore production of green hydrogen. And therefore the seawater treatment is an important part of this whole facility, which is needed. And to build up this whole process chain, we have everything you need on such an offshore wind platform. We have the wind turbine for generating the electricity, or the green electricity, and this is important. You need it for the electrolyzer. You also need the electricity for the desalination unit, and you also have the water capacity you need there. It's available there. You need for the process, and now our task is to transfer our ideas and our concept to application. And this we want to do with full-scale dynamic tests at our test field in Bremerhaven. We want to investigate critical operation modes and with coupled processes, so heat extraction is one topic or one buzzword I want to mention later. And yeah, we want to analyze sculling and fouling without the use of chemicals, and we also want to test or to check the water quality to make sure that we have a constant quality of the water. I skip to the next slide. Yeah. But let me start. Yeah, water. You need or you can't use any water you get for the electrolyzer. So for the process, you need ultra pure water. You can't use drink water, groundwater, or seawater directly, also not yet. And yeah, but for this, yeah, you have to treat the water to make from maybe groundwater or seawater to make pure water, so that you can use it for the production of hydrogen. And for this, yeah, you need a unit. In our case, for the seawater, is it a desalination unit to filter out all the stuff inside the water, which yeah, you don't need for the electrolyzer. Some like organisms or minerals and so. And yeah, this process I want to show you on the next slides. And I have mentioned here some numbers. So can say for 10 liters of pure water, you'll need between 30 or 100 to 100 liter of groundwater or seawater. And yeah, this amount of water depends on which kind of system or desalination unit you use. But yeah, that's a rough number, so that you have an imagine of what we are talking about, what amount of water we need for our process. So, yeah. So, but for the use of water, we have to take care of some aspects. I want to tell you why we want to use seawater and not groundwater, because yeah, in these days and age, with the climate change and the things which depend on it, it's very necessary to make sure that you have a responsible and sustainable use of water. And maybe for groundwater, we have the problem that we get in conflict with a competition demand for the use of it. Because yeah, the level of dry increases, not only in Germany, I think all over the world or here in Europe. It's a problem, and it's not on a critical level yet, but forecast for the next few decades of years, yeah, it looks not good. And especially when we have in mind that hydrogen production also increase as well in the next years, maybe it become critical when we want to use groundwater. And yeah, so we have limited quantities for it. And yeah, it's in competition of demand for other uses like drinking water or for the agriculture. And so I think the same depends on water from rivers. And yeah, so you can use discharge water from industrial plants or from sewage plants, or you use seawater. And in our case, we want to use the seawater. And yeah, there we have to face some challenges in our project, because yeah, the seawater contains yeah, a lot of minerals or organisms and solids, and have a salt concentration of between 3 and 4%. And on add to that, we also have changing water conditions. So we don't have the same conditions every day, every time. So it depends on weather, rain, storms, or seasonal changes. And the next point, and I think that the biggest challenge is that we have dynamic operation conditions when we work at such a wind turbine platform. Because we have full load operation, we have continuous operations, we have no operations, we have startup behavior, and so on. and so it makes it very difficult to build up a constant process for the water treatment. So yeah, this we have to keep in mind and we have to face, and yeah, this we want to test on the project, and this we want to test in our test infrastructure in Bremerhaven. The test infrastructure for hydrogen is still in preparation, and I think it will finish during this year. And there we have not only the possibility to test seawater or the seawater treatment. So there, yeah, let's say we can test nearly everything around the topic of hydrogen, because we can test the electrolyzer, we can test the fuel cell. We have a power grid, or we can test the power grid connection. We also have a connection to a wind turbine, and we have storage possibilities. We have trailer to filling up the hydrogen, and yeah, a lot of topics. And besides research topics, we want to provide our test capacity for the industry, and maybe to test different kind of electrolyzer and so on. But now I want to come back to the point of seawater treatment. As I highlighted here in the white quarter, you can see where we planned our location for the seawater treatment, and this whole test infrastructure is not ready yet. So at the moment, we only have this big seawater pool with 100,000 liter of seawater. And yeah, there we want to build up our test infrastructure, and of course it's not already ready yet. I have a small sketch here on the right side. So beside our seawater pool, yeah, and the desalination unit, we have yeah, the pumps are needed. We have some filters to filter out some organism and so, and we have also the connection to our electrolyzer. And another topic we want to pay attention is the heat extraction. So for the desalination process, you need you need heat, because we have to heat up the water. And for this, we want to use the process heat from the electrolyzer to make the whole process more efficiently. And yeah, what's important to say is here we have a closed process, I would think. So we would process here, yeah, in a circle. So our main thing is that we want to treat the water, and we have different water tubes which go back to our seawater pool. And every tube we have the possibility to take some water probes and so, and to check the quality under different conditions we are driving there. We can use different salt concentration on the seawater, different temperature for the seawater, different heat temperature for the desalination unit. Yeah, this all the stuff we want to test. And then the main point is that we want to collect a lot of data. So we have put there some sensors at the tubes, so we can measure the temperature, we can measure the conductivity, the pressure, the flow rate, and all the things. And yeah, we want to collect the data and want to interpret the data and evaluate the whole process to find out the output rate for the different operation modes we can drive with our facility. A short sentence to the marked cooling system. There, I have marked this because that would be a part in our test infrastructure, which we only have on our test field. So when you have it on a wind turbine or on an offshore application, we wouldn't use this cooling system, but for us it's necessary to take care that the temperature of the water in our seawater pool does not increase more than 20 degrees because of the process heat we had. The temperature of the water increases, and with the cooling system, we want to make sure that we have constant temperature in our system, because we want to test with temperature between 5 and 20 degrees of water, and therefore we need the cooling system. Why we are testing? So the reason why we are testing at scale is that we want to find out the output of pure water and what we have to put in on energy, and how much seawater we need to produce 1 liter of ultra pure water. And this we want to find out under different kind of perspectives. So one perspective is the reliability of the desalination unit. We want to identify the maintenance effort. We want to identify the vulnerabilities of the whole unit. We also want to find out how the reproducibility, so we can make sure a consistent water quality during the whole process, during the changing process parameters, and so. And also, do we have a consistent production quantity of the water we produce? And this we want to test under dynamic process conditions, as I mentioned, because the seawater temperature change, the conductivity of the water change, the process heat or the heat for the desalination unit we need, this also changed, and this all we want to build up on our big test scale in Bremerhaven. And at last, we want to find out how flexible is the system, because we don't have this continuous operation on a wind turbine. We have also stop the whole unit, and how is the startup behavior, and all things like that. We want to find out. And but as I mentioned, our test infrastructure on the big test field is not ready all yet, but we did some small tests now in another facility. And you can see here in the blue container, we have a desalination unit. We decided to use a vacuum distillation unit because in the project preview, we had the opinion that this type of unit is more useful for the dynamic modes we want to test, or we have on wind turbines, and so that was the reason why we picked up this type of desalination for our project. For first tests, we built up a small scale test. So we don't have a big 100,000 liter seawater pool. We at the moment use a water IBC with 800 liters of water within synthetic salt concentration. And there we also process and cycle. So every filtered component goes back to the seawater IBC. And so we also need a cooling system, like I mentioned before. But on every water tube, we have some wells to pick up, to take some water samples and to check the quality. And we also generate data there, because we also have to, or we have temperature sensors, conductivity sensors, and so on the tubes. So we also collect a lot of data, like we planned on the big scale test. But for us, it's important to find out first impressions of the unit, how works the unit, and is everything fine? And so the small test bench is a good possibility for us to start and find out some some interesting stuff. The heat extraction here is not used because we don't have an electrolyzer there, so this we don't use at the moment, and that's a topic we want to take a look at when we are at the big test scale. What we want to find out, or what we find out at the moment, is that we drive the desalination unit with different temperatures between 40 and 60 degrees. And we did some tests with seawater temperature between 2 and 20 degrees. And we had some long and some short run operation modes. We run the system to get a feeling, okay, how is the behavior? How long does it take that the unit starts to produce the ultra pure water? And what we find out is that we still evaluate that the data we collect during the tests now that we have a small impact on the delivery rate and depending of the temperature of the heater. So we have between 250 and 280 liters per hour of pure water we produce at the moment, and we find out that we have a different amount of process time to start, on the start time when we have different temperatures. So when we have a low temperature and the system is running, then it's okay. Then we can produce pure water with the same amount of water we had on a higher temperature. But when we start with a temperature between 40-45 degrees for the desalination unit, then we have a longer time still the system is running and produce pure water. So that are the first things we find out. We're still looking forward to make further tests and test setups, and we are happy when we can switch with the desalination unit to the big test field and can really start our test program and make our contribution to the successful implementation of the H2Mare project. And that's everything I can tell you about that at the moment. And thanks for your attention, and I'm interested in your questions you had. Thank you.
Yeah, thank you very much, Oliver. Almost a perfect landing. Just in time to answer some last questions. Gianluca Carigi is asking, how is the waste heat from electrolyzers used for water treatment? Was it the technology you use for water treatment, or is it reverse osmosis?
No, it's not the technology we use for the water treatment. There we want to use a separate unit, so a separate heating system, heating cycle, and to get out the heat temperature or the heat energy from the electrolyzer, and then it goes over to a heat exchanger, and where we transfer the heat from the electrolyzer to our normal heating system from the desalination unit. So it's not. Let me show the answer. What was mean with was it the technology you use for water treatment? Sorry, I'm not sure if I understand the question right, but it's so how it works. So it is a lone standing system for heat extension, and I hope I answered your question. Sorry.
Okay, Gert Devish is asking, what is the ideal water quality in microsiemens value to put a maximum load of the purified seawater with good return?
I think the optimum conductivity is 0.05 microsiemens. We want to achieve for our pure water. I think I mentioned it on the second or the third foil or slide. So I mentioned here that the conductivity should be smaller than 0.1 microsiemens, but in our test we had a conductivity level of 0.05 microsiemens.
There's another question by Niusha Alinia. She's asking, are you also considering coupling the SOEC test facility at IWES with offshore hydrogen production?
That's a question, yeah. I don't think so. So I don't know if there are any ideas to do that. So as I know, it's not planned.
Okay, Martina Nast is asking, which systems will you be testing? Reverse osmosis and or distillation? And what do you think are the biggest obstacles in pure water production offshore?
So at the moment or in the project, we don't testing the reverse osmosis. So we are testing a vacuum distillation unit. But our idea is to test not in the project, but beside the project, different types of desalination units. So also some reverse osmosis or a unit which works with the reverse osmosis. And I think there we are in contact with some manufacturers which want to test their units here. And so it's planned to test different types, to compare different types, to see how they work when we use them in dynamic process modes and so on. So that's the idea. But at the moment, our unit works with a mixed vacuum distillation. So we need a temperature between 40 and 50 degrees, and we have a vacuum unit which is integrated there. And yeah.
Okay, final question, I would say. Two similar questions by Gianluca Carici and Wolfgang Schleifenbaum. They are asking, are you adding chemicals to prevent scaling and biological growth?
No, at the moment not. I think also it's a point in the project that we don't want to add some chemicals to prevent it. Because when we operate between 40 and 60 degrees, so that is the temperature of our heating circle, of our heating system. There we have this works with water glucose mix, and so there we use chemicals, but I think that's a close process. And but in the seawater and after the desalination in the pure water, and so we don't use chemicals. Also not at the moment at our small test bench where we had these 800 liter water IBC we are testing with. There we use at the moment we use no chemicals, and we don't want to use chemicals.
All right, so I think we are done. Thank you very much again, Oliver. And again, unfortunately, we cannot answer all the questions. Thank you anyway for all of you who asked our experts today. By looking at the time, I would say let's call it a day. I'd like to express a
One
warm...
last question, Christian. One last question.
Yeah.
Is it possible to answer the question here in the chat, or when the seminar is closed, then it's not possible? Do you know that?
I think when we go offline, it is not possible anymore to answer the questions.
Okay.
But we will get the answers, and maybe we can have a look at them. But anyway, if there are questions left, feel free to get in touch with us afterwards. You can find the contact information on our website. And I'd like to express warm thanks to all of our speakers for sharing such exclusive insights with the audience. Cheers to you, also the audience, for participating and showing such huge interest in the work of H2Mare. We would also love to engage with you on our LinkedIn channel. You are welcome to visit us at our next events, and this is the last slide. There are our events. You can find us at Hannover Messe in April. Also, we do our H2Mare conference in June in Berlin. If you want to come around, and we would love to see you there. For now, I wish you a pleasant rest of the day. Goodbye and take care.